Good evening, everybody, and welcome. My name is Chet Kamen. I am a trustee of the Leakey Foundation, one of our sponsors tonight, and an avid supporter of our other sponsor, Chicago Council on Science and Technology. Special greetings to those who are not here physically but are joining us on live stream. And a big thank you and shout out to Chicago Public Schools and Walter Payton College Prep for hosting us tonight. They've been terrific. As I suggested, tonight's lecture is presented as part of a series through a collaboration of Chicago Council on Science and Technology and the Leakey Foundation. C2ST, as we refer to the Chicago Council, is a 10-year-old not-for-profit organization that seeks to enhance the public's understanding and appreciation of science and technology and their impact on society. I go to their programs, I'm on their mailing list, they're terrific, and if you're not already signed up for that, I strongly encourage you to do that. We're celebrating the 10th anniversary of the founding of C2ST, and there's a fundraising campaign called The Power of 10, and you're invited to make a $10 donation on the C2ST website, c2st.org. And you can also find on their website upcoming programs, and you can sign up at the tables outside to be on their mailing list for notifications. The Leakey Foundation has as its mission to increase scientific research and public understanding of human origins, evolution, behavior, and survival. The Leakey Foundation is about to celebrate its 50th anniversary. It's been doing this for a long time, all around the world. And our foundation is interested in the big questions about what makes us uniquely human. Why did we begin walking on two legs? How did we develop language, art, tools, and other attributes of culture? What makes us different from other primates? How are we like other primates? Questions like that. The foundation explores these questions by funding research and sharing the results with the public through events like we're doing tonight, and with our really wonderful podcast, Origin Stories, which I heartily recommend to you. Again, there's another table for the Leakey Foundation to the left of the door here, and you're welcome to get more information and also hopefully make a donation. And we have a great website, and also we're on Facebook and Twitter. A couple of housekeeping matters. This is a new generation, I'm finding. I'm not asking you to turn your cell phones off. I'm inviting you to leave them on, put them on vibrate, and take pictures and use them to Twitter out to broadcast what we're doing here tonight. There will be a question and answer session. There will be representatives with microphones. Please wait for the mics, because otherwise people will not be able to hear you, particularly those who are online. Now I'm very pleased to introduce Zerai Lemzaged. He's a professor of organismal biology and anatomy at the University of Chicago, recent transplant to Chicago. We're very delighted to have. He's a Leakey Foundation grantee and a prominent leader in the field of paleoanthropology, and Zerai will introduce our distinguished speaker.
Thank you, and good evening. I just moved to Chicago a year ago from San Francisco. You may be saying, what an idea. But I'm liking Chicago. And I'm really happy to say that the association that I had with the Leakey Foundation, which, as was mentioned earlier, supports the very idea of the very study of human evolution and where we come from. So I'm happy that that collaboration with them is continuing, even though I left San Francisco and joined Chicago. And today, I'm very honored and feel privileged to introduce Dr. Isaiah Nangou, who is our speaker tonight. Isaiah is an associate director and research professor at the Turkana Basin Institute, which is associated with the Stony Brook University. He holds a BSc in Zoology and Botany from the University of Nairobi and a Ph.D. from Harvard in Biological Anthropology. He was a Fulbright Scholar at the National Museums of Kenya and the University of Nairobi in 2012 and 2013. And his research focuses on the search for the ancestors of apes and humans. And that is really important because people like myself are interested in exploring what makes us human, starting with walking on two legs and having a big brain and making tools and inventing languages, arts, etc. But as everything, that package also had an origin somewhere. And that's why the work done by Isaiah and his colleagues is really relevant to the very idea of where we come from. Isaiah has made many fossil discoveries, including the one that he's going to talk about today. Nyanzapithecus Alesi, which belongs to a group called Nyanzapithecines that are associated or affiliated with the great apes. And as you very well know, we are members of the great apes. So the very talk that he's going to give today is going to be very relevant to the origin of humans and apes. So without further ado, I feel privileged and honored to invite Isaiah to come to the podium and share his exciting research with us. Thank you, Isaiah.
All right, I like to move around, so I'm going to get out from behind the podium. And I'm going to pass, I have a 3D print of Alesi, and I want to pass it around so you guys can handle it, get a sense of size and what we have. It's a pretty accurate 3D print as we begin our conversation. So I'd really like to thank the Leakey Foundation and the Institute for having me here. It's been a great day. I've been talking to the high school students, and I feel really, really great about this. This is the first public lecture I'm giving since we found, we discovered the fossil, Alesi. And so I want to take you back 13 million years ago into a corner of Africa around Lake Victoria, around Lake Turkana. And it is here that at a site called Napudet, that about 13 million years ago, there was a massive volcanic eruption. And it belched out piles of volcanic ash. In the beginning, threw out ash that was mixed with these boulders. And in places you can see, like on the right-hand corner, you can see a boulder still sitting at the position of impact. And then it proceeded to just pile out these meters, almost 10, 20,000 tiny meters of ash, blanketing the whole of the landscape. And here you see a tree on the bottom left side. You see a tree standing upright, or what is left of this tree standing upright. And at this site, there are about 90 trees still standing upright. And it just buried everything that was in the landscape. So in there were elephants, there were rhinos, there were pigs, and amongst all these things that were buried was a fragile little body of an ape. And so ash, volcanic ash, has got a mineral that is almost like cement. When it gets wet, it will percolate. Of course, the flesh is going to disintegrate. It's going to percolate into the bones, and the bones are going to get hardened and become fossils. Really, really good at preserving fossils. So that was 13 million years ago. Let's fast forward to 1990. A team of fossil hunters led by the intrepid great fossil hunter Kamoya Kimeu, who worked with Richard Leakey for all these years, and the team was called the Kubifara Research Project team, were out there scrounging around looking for fossils, and they stumbled upon this scene, the leftover of this great volcanic eruption that happened 13 million years ago. And they found the trees. It's a spectacular sight when you see those trees. It's just, you don't often see anything like this. A whole forest buried with stuff in it. They picked up a canine of an ape. They picked up a few pieces. And then, as often is the case in the Turkana Basin, there are a lot of hominids, so they got distracted, in my opinion. They got distracted by the hominids, and for the next almost 20-something years, everybody had forgotten about Napodet. So 2012, I had a Fulbright. I went to Kenya. I went and talked to Meave, and I said, look, I would like to start doing some new research in the Turkana Basin. Up until then, I'd been working on the western side of the country. I'd like to work in the Turkana Basin, and I'd like to work at a site that nobody has worked on much. Can you think of anything? And she recommended Napodet. So I went to Napodet with my son and a few other people. We spent 10 days, and right on the 9th day, the day before we left, we found the site. And so I came back, wrote a grant to the Leakey Foundation, and I got the grant, and we went. And on September 4th, 2014, at about 5:30 p.m., after a long day of looking for fossils without finding anything, and we were really tired, one of my assistants, John Ekusi, began rolling a cigarette, tobacco cigarette. We got mad at him, we chased him and said, go smoke your cigarette somewhere else. And so he walks in front of us about 200 yards, and we see him stop, starts milling around. We're like, why is John going around the same spot? Has he found something? Maybe he has found something. So we pick our pace, we walk, we start yelling at him, hey, John, did you find something? He says, yes, I think I found something. I say, what did you find? He said, I think I found the knee of an elephant. And so we get there, we take out a brush, we brush it aside, and we see just what you're seeing. That's a picture taken that day when we found this fossil. And the position of the eye socket was enough to tell us that we had a primate. Not only did we have a primate, but it was spectacularly well preserved. So we knew we had hit some kind of jackpot. We just didn't know how big the jackpot was. So what I want to do is I want to go back and share with you, because you don't see too many African paleontologists. You don't see too many black paleontologists, to be honest. And then especially you don't see too many people like, look at me, running around looking for apes or anything else. So my story is interesting. It's unusual. My career path is very unusual. I've not done things the same way people do them. And so I thought that it might be interesting to share with you a few facts about my life. Right, so my family comes from a place in Western Kenya near Lake Victoria called Kogelo. For most of you, up until a few years ago, it meant nothing. But I think now it means something because it so happens that where my father comes from is the same place that a very famous citizen of Chicago comes from by the name of... Right, you guessed right. So I think my father at some point when he was young, way back in the 50s, like many other men and women joined this migration to the city to seek work, make money, buy bicycles and sofa sets and record players and other useless things. And so I was born in Nairobi. Then my father retired, my parents retired, and they're back in Kogelo. So you can see my father milking his cows. They lived not too far away from Mama Sarah, Barack Obama's grandmother. Anyway, so I grew up in this really rough, tough part of Nairobi. And so when I was 17, I was in high school. And we were told one day, hey, you guys are going to go on a field trip to the museum. And we went to the museum, we went and saw the exhibits, and then we were told, you're going to get a lecture from somebody famous. So we were marched into an auditorium like this, and we sat down, and somebody walked in. And it was a white guy. It was the first time I've ever met a white guy. And it was a tall white guy, walked in, and introduced himself. He said, I am Richard Leakey. And he gave us a talk on plate tectonics and evolution. And even as a kid of 17 years old, I was blown away. There was something about the story. There was something about it that was so universal, so transporting, that even for a 17 years old kid, it grabbed me. It hit a chord. So that's how my passion for paleontology got ignited. I didn't think much about it until I went to University of Nairobi. I got a bachelor's degree in biology. I remember on my second year, we had to have a class in evolution in order to graduate. The problem is there were no professors who wanted to teach evolution because they were all creationists. So finally, the chair of the department had to teach the class. And so he came in and he was honest. He told us, look, I'm a born-again Christian. I don't believe in any of this, but I'll teach it anyways. And, and then he decided, look, to be fair, I know there's an evolutionist in Kenya. I think by then Kenya probably had only two evolutionists, Louis Leakey and Richard Leakey. But and actually, the day I later on came to realize that when he gave a talk about plate tectonics, there was a newspaper article that was blasting this news that Leakey says Africa is splitting into two. So not only does he say we come from monkeys, but he's also splitting Africa into two. Damn Leakey. Right. So anyway, so he walks in, and I was absolutely taken over. But anyway, so it's a second year, the professor invites Richard Leakey for a debate. They had a debate in front of the class. We got to vote. We all voted that Richard had won the debate. So I graduated, and I had to think about what I wanted to do, and I decided I wanted to do something that I had a passion for. I said, what do you have a passion for, Nengo? And then I just realized that I wanted to be a paleontologist. So I wrote a letter to Richard and me, and I said, I want to be a paleontologist. And lo and behold, they wrote me back. They invited me for an interview. So I go in, they tell me, okay, good, but there's no job now, we'll call you back. I went home, came back a week later. I said, I'll volunteer. I don't need to be paid. So They say, this kid is serious. Has he been smoking? so Meav took me by the hand, walked me into an office. He said, this is going to be your office. And she then walked me into the lab and said, you're going to help us reorganize this collection. And she gave me a book. I still remember, it was The Evolution of African Mammals by Magley and Cook. And so Meav walked me into the lab and introduced me into the Miocene fossil collection. It's probably one of the best Miocene fossil collections that exist anywhere in the world. It's really, really a great fossil collection. So she said, your job is to go through every single specimen, make sure they have records on it, make sure that it's identified correctly, and you will learn what they are. So I learned what an elephant looked like, what a Miocene pig looks like. I met these strange creatures called anthracotheres that I've never heard of. Elephants with tusks that faced downwards. I was blown away. I was in a world that I only imagined lived in cinemas. And I was just absolutely fascinated and taken by this thing. And so the Miocene, this diagram is kind of backwards. Usually the oldest period goes from left to right, so you're just going to have to do this mental jiu-jitsu to read it from the opposite direction. And so it is this period after the dinosaurs go extinct when the mammals diversify. And first of all, it starts off in the Paleocene and Eocene being very warm, and then the Pleistocene, it got very cold in the Oligocene. The Pleistocene is also very cold. So the Miocene is this period is sandwiched between two cold periods, right? So it's pretty interesting, this time period called the Miocene. They also introduced me to the importance of Africa in understanding the evolution of mammals. Now we know that Africa is 1/5 of the land surface, 1/3 of mammal species are found in Africa. So 1/3 of mammal species are found in Africa. That's important. The largest mammal, largest reptile, the largest primate are found in Africa. Then there's also this primate that walks on 2 legs, has a big head, likes to eat hamburgers, warm up the damn globe, think it's very special, also came from Africa. And as you learn, it's not only the ancestry of humans that can be tracked down to Africa. I've come to really believe that the ancestry of the great apes is African. The ancestry of the ape lineage is African. The ancestry of monkeys is African. I think that for a period of 30 million years, Africa has been acting like a petri dish where experiments in the anthropoid lineage are tossed out one after the other. Most of them go extinct, but occasionally one of them leaves and ends up in Eurasia. And that's the latest one, the most famous one, the out of Africa that we are familiar with, is humans out of Africa. But I like to claim that humans is only the latest of a series of things in our lineage originating in Africa and ending up in Eurasia. So if we go back to the Oligocene, when the dinosaurs go extinct, 65 million years, the mammals had not been doing very well until the dinosaurs left. So the dinosaurs leave, and so throughout most of the early part of the Cenozoic, Africa is an island. It is not connected to anything. You know, Eurasia and South America and North America are connected through the Siberia, but Africa is isolated. So Africa develops or evolves a very unique set of mammals. We are now putting them in a group called the Afrotheria. One of them is the elephant, the hyraxes. The things that ate meat were not the lions that you see today. There were things called the creodonts. And then you also have primates. If you move into the Miocene, you begin to have a process of modernization. You begin to have a modernization because there's a route that is opened up between Africa and Eurasia. And some of the things that we now associate with Africa begin to show up. You begin to see rhinos, which had been evolving in Eurasia, pop up in Africa, giraffes, pigs, and ancestors of some of the ancestors of modern carnivores, like the bear dogs, also show up. Middle Miocene, you get the addition of the ancestors of what we now think are typically African animals, the gazelles and the buffaloes and things like that. The ancestors don't show up. They don't show up in Africa until the middle part of the Miocene. And then lastly, you get the arrival of the Hipparion. Hipparion was a genus, a long-lived genus of horses that evolved in Eurasia, and they eventually end up in Africa in the late part of the Miocene, starting about 5 million years. So there's been a long process of Africa started off looking very, very different from the Africa you see today. And now it is this Africa that you see today. Part of it is a result of migrations, part of it is tectonic activity in the East African region, breaking up of the vegetation, all this stuff. And that's what I've become interested in, is trying to understand all these processes, how we set up the stage so we can understand how humans came to be. Right, so I did not like school. I worked at the museum for a few years, for actually a few months. And then Richard told me, you gotta go to graduate school if you wanna do this seriously. I said, but I hate school. He said, no, you gotta go to graduate school. I said, where should I apply? He said, you should apply to Yale, Harvard, Stony Brook, and Duke. They're great programs in paleoanthropology. So I sent in applications, and they all mailed back, and they said, I got rejection letters from all of them. I was a bad student. And one professor from Stony Brook wrote back to Richard and said, man, that guy has the worst grades I've ever seen in my life. I can't believe he wants to go to graduate school in America. But he's got these great recommendation letters. His recommendations letters say he's the brother of Jesus. So it's kind of curious. The best we can do is we can admit him as a special student, but you have to put up the money. Richard said, I'll put up the money. So I came to the United States to travel around. I went to Harvard. And by then, Richard had given me a couple of books to read by some guy called Stephen Jay Gould. I was just blown away by the way Gould thought. His writing, his thinking was just, my goodness, I thought, this guy is fantastic. If I could just have a chance to learn with these guys, I would be in heaven. So I went to Harvard to visit with my person who became my main advisor, David Pilbeam, and we were sitting there in the afternoon about noon, and I tell him, hey, look, I've been admitted as a special student at Stony Brook. Do you think Harvard can do me the same deal? And he says, oh, yeah, but it would be a lot more money. And I said, let's call Richard. So we dialed Richard, and it was still the days of the dial. And Richard did not blink. He said, yeah, I'll put up the money. So a few months later, I ended up at Harvard as a special student. I did well enough, and they took me in as a regular student. I proceeded to study my PhD. So very first year, I'm looking for courses to take. And at the end of the catalog, I see that this course is called Readers, where you can take a one-on-one class with a professor of your choice if they'll agree to take you. So I was kind of naive, and in those days, I didn't know who really Gould was really. So I marched over to the MCZ and knocked on his door, and luckily enough, he was there, and I said, hey, I want to take a reader with you. And he looked at me, and he said, okay. So I had a course. My introduction to evolutionary theory was at the feet of a real master, the best education I've ever had. I mean, I can't tell you how wonderful it was. We read everything, Agassiz, We read all the classics. We read Darwin. I had a guided reading of The Origin of Species. I mean, it can't get better than that. It really cannot get better than what. There's not a greater Darwin scholar than Stephen Jay Gould. Amazing. Anyways, so that's why I put that book. That's one of my favorite books from Stephen Jay Gould. Great breadth. He shows you the connectivity of what we are dealing with. That someone who studies snails can write one of the best pieces of writings that have ever been written on human differences. All right, so we can understand humans because what we are looking at is universal. All right, so that's where in one of our readings, one of our early readings, because so okay, Darwin doesn't say very much about humans, so we need to look at somebody who says something about humans. So the very first person to try to stretch the theory of evolution to encompass humans was Thomas Huxley in The Descent of Man. And long short, he identifies one of the key problems that we need to address, one that we're still wrestling with right now. The one that brings us all here is, what's man's place in nature? Where did we come from? How did we come here? Is it through creation? He said, no, it wasn't through creation. The theory of natural selection applies to us as well. So we evolved too. And how do you know? How do you demonstrate that? The only way you can properly answer the question of what our place is in nature is you have to look at it in the context of the apes. You cannot understand human evolution if you don't understand ape evolution. There it is. And so where do we get these ape fossils? If we want to understand evolution, where do we get the fossils of apes and humans? 1871, there are no fossils. I mean, it was a terribly difficult problem. They could be in Asia, they could be in Africa, they could have been in Antarctica. Nobody knew where to look. It was all, So what does Darwin say? He says, some of those, 3 of those apes are in Africa. I think you guys should look in Africa. Of course, everybody ignored Darwin. They went looking anywhere else. They did not look in Africa, right? And the very first person to really begin to seriously look in Africa is, I'll show you that later in a second. So we've really come a long way. Let me see that. Okay, that was supposed to come first. So there's the first ape fossil. Actually, let me see. No, I don't want to do that. I want to do this first. Yes, I know why. Right, so since 1871, when Darwin predicts that human origins are going to be in Africa, we've come a long ways. Look at that tree. And the works of people like Zerai has been amazing. Look at that tree. We've come a long ways. However, Huxley says, and there's no way you're going to understand who we are, where we're from, what we are, if you only look at one side of the branch. You got to look at all the apes. I like to, so you have 2 great-grandparents, and one of them was very successful, or so you think, was a great guy. One of them was an alcoholic, right? But they came across the ocean, they made it, and now you're telling your story, and you want to leave the alcoholic out. You're not going to know who you are. You got to have everybody. So if you look at in this, you're going to see at the corner there, tucked at the corner away is what? Is the branch. If you come to think of it, if you look at it in movies, in popular culture, in the way we think about ourselves and the way we think about evolution, we have a very uneasy relationship with the ape branch of our family. We don't get as excited about the ape branch of our family as we do get excited about the human branch of our family. So we tuck him away over there. If you go into the Google and you Google hominoid or human evolution, or you're going to see trees for this. But you're never going to find trees for the ape side of our family. If you look at the effort that we put, the money, and whatnot. And that's why we've done such a great job. We put a lot of effort on this side, but we don't put a lot of effort on that side. And so I told Richard the other day, I don't know why you get so excited about the humans. So I am looking for the forgotten, the ignored, the drunk grandfather that we all don't want to be associated with. I'm going to dig him out, bring him out, and we're just going to have to deal with him. Right, so I'm not the only one. It all started with Eduardo Duarte in 1856. The first ape fossils was those of Dryopithecus, found in France. And then Guy Pilgrim found ape fossils in Pakistan, and my advisor followed in the footsteps of Guy Pilgrim and ended up finding that beautiful skull of Shiva-Pithecus. And then in Africa, we had Tyndall Hopwood, but the two people who were primarily responsible for turning the tide and shining the light in Africa was Louis Leakey. Everybody thought Louis Leakey was crazy. You know, so he goes to Cambridge and he's done, he says, I'm going to go to Africa to look for the links, missing links. And Louis Leakey was special in that he was one of those people who looked for, he really grasped what Thomas Huxley was talking about. You cannot understand humans without looking for apes. So Louis Leakey was spending his time looking for humans and also looking for what? Looking for apes. Spent a great deal of time looking at apes. And he celebrated the findings on both sides with great fanfare. You know, who can forget the time when they discovered what's called Mary's skull of proconsul, now known as a Kemble? Or when Louis, with his enthusiastic, his infectious, zeal, discovered Kenyanthropus, and he said, we found the deep roots of humans in Kenya, at Fort Talon. So Louis Leakey and Mary Leakey really put us in the right place. And it's only after Louis and Mary Leakey that people started to look for humans and also kind of started to look for apes in Africa. But more emphasis on humans and not as much on our drunk grandfather. Right, so I finished Harvard. I got a job at UC Berkeley. I taught there for a year. Then I was hired to teach in Ohio. I taught in Ohio for 5 years. And then I became disillusioned by the fact that when I looked at my classes, they didn't look like America. When I went to the classes today, I've been talking to those kids all day, and because it looks like America. It looks like, the white kids, Asian kids, Latino kids, black kids. And with the story we're trying to tell, the story of all people, all of us. And I'm thinking, where's everybody? Why am I only seeing white kids? Where are the Asian kids? And by the way, here I'm a black guy. Why am I not able to share this story with a broader range of Americans that I know exist? So I decided to leave, pack. We packed our family. We moved to California, go west, my friend. And I took a job as a high school teacher in East Oakland, in the inner city. For 2.5 years, I taught biology. And then I decided to go to a community college. So I went and taught community college. For 13 years, I lived in Marin County, I taught at community college in Cupertino, because we have a beautiful house in Marine, and I loved the Anza College. And so I did this 1.5-hour commute on a good day, one way, for 13 years. And some of the best times of my life has been teaching evolution to a broader audience, teaching introductory classes where I'm teaching natural selection and Darwin and the origin, sharing some of the stuff that I learned from Stephen Jay Gould with a broad range of Americans is one of the most beautiful things that I have ever experienced. So in 2012, I decided to make another turn. I decided, oh my goodness, I had collected all these fossils from Western Kenya. It's time to go back and describe them. So I applied for a Fulbright. I got it. And I went to Kenya and restarted doing fieldwork. And that's when I went to see Meav, and I told her, look, I want a new site in Turkana. And so she told me about Napodet, and now we've gotten back to our story. Right, so one thing I've come to believe is that it is critically important to engage young students in our research. I drag undergraduate students. I don't think many of my colleagues do that. They find undergraduate students to be a nuisance. I take undergraduate students with me to the field. I work hard to try and find resources to take any student who's interested, regardless of their means. And I've managed, and the Anza College is a special place. Over the last 3 years, they've managed to find money, and this is a community college. In 2014, I had 4 students. 2015, 4 students. Last year, in the summer, I had 14 students paid for. We managed to raise money and take these students to Africa. Many of them students who some had never left the United States. And you can see photos of them being in the field, building tents, living with everybody. This is last year at Bullock. We had, 26 people out there. We visit local communities, and they learn hands-on by doing research, being in the real thing. That's how Richard and Meav taught me. They said, go out there, look at those fossils, organize them, go into the field, and get burned up. So there's something I really, really strongly believe in. It teaches patience, it teaches persistence, teamwork, delayed gratification, all the things we try to teach. But in 3 weeks, in the heat, in Turkana, and who would have thought that you could take American students, deny them cell phones, work them half to death, and then they'll come back and say, this is the best experience of my life. I didn't know that. And there's Kelsey. The day she found an elephant tooth. And it's like she's died and gone to heaven. It's amazing. And so we returned to Napodet in 2014. When I got the grant, actually when I was working on the grant, I tried to invite a number of colleagues to come with me. Nobody wanted to go. I don't know why. Somebody who was supposed to be my geologist bailed out on me the last minute. I got to Kenya. I could barely put together a team because nobody wanted to go. The thinking was that if the Leakeys had worked somewhere, and they're not working there, there's nothing to be found. So I couldn't find anybody who really wanted to go. The cook disappeared, and we had to look for him for 3 hours. And we're so short-handed that we eventually managed to scrounge a high school student. Bernard was a high school student. In fact, we woke him up taking a nap. Say, get up, we're taking you to Napodet. to do field work. Right. So that's the very day when we found Alesi. And so we cover Alesi up because it's 5:30, there's nothing we can do. We go to camp, we sleep, we wait for the next day. Nobody slept. I didn't sleep that night. It was just because I knew, this thing is out there. By 5, everybody was up. Usually we leave camp at 6. That day, everybody was up at 5, ready to go. Then at 6, we left. Then we saw a crowd. They stopped us. They said, "What are we doing here?" We had to negotiate. And coincidence, I don't know. I mean, they had to show up on that particular day, of all days. They had to show up at that moment. It was terrible. So we had to negotiate for 6 hours. They finally agreed to work, to let us go. So we went in, 4 hours, we excavated. And here is, let me see if I can get this going. Yeah. So there we are uncovering Lessee on September 5th at around noon. And that is Nyete, who is the team leader for the Kubifora Research Project. He's taken over from Kamoya Kimeu. He's the new Kamoya Kimeu. He calls his team the A team. And then Kamoya told him, "No, you are the B team." So that's Alesi having been lifted, and we put in a sandbox. And that's John Ekusi, the discoverer. You hear me sigh at the end. All right, so we brought Alesi back to TBI, and the Turkana Basin Institute is a fantastic, it's got an Arctic research center. This is like the Arctic Research Center of Paleoanthropology, built in the middle of these really harsh conditions. We have 2 centers, we have 2 facilities, one on the east side, one on the other side, the west side of the lake, and it really makes research a lot easier. You don't have to track in supplies from Nairobi. You can just tell us what you need, and then everything is available. So we took it back to TBI Tarkwell, and it was prepared. This is a shot showing you Alesi being prepared, and this is after the preparation. And I was not there when it was being prepared. I was back in the United States, so I hadn't seen it. I'd just seen the photos. And then it really is a spectacular fossil. If you're a fossil lover, it really is an amazing fossil. So here is our landscape at Napotec. We went back the following year and we excavated, and we did not find anything more of Alesi. That just gives you some sense of what that landscape looks like. The wind is always blowing. Smack up in the middle, on the bottom of the hills. All right, so if you see the specimen being passed around, you'll see that the teeth are gone. The erupted teeth are gone, the sutures are open, so we know we have a subadult. In the front, the central incisors are just beginning to peek out. So we had a sense that more of those unerupted teeth were inside. And that if we went in and scanned it, we would get to see the teeth. And it so happened that Max Planck's Institute was going to bring a micro CT scanner to Addis to work with Zerai. And I got in touch with Fred Spohr, and he said, look, if you can arrange to bring Alesi to Addis, and Zerai was generous to allow us to do that we would get this Alesi scanned. And then just about a week before we were to leave, the scanner broke down, and we already bought the ticket. So we agreed with Spohr that I would just come, we would do a medical CT scan to see if at least there were teeth inside. So we met in Nairobi in February of the following year. We scanned it, and sure enough, there were teeth. And also, there was enough from the medical CT scan because, you know, babies are notoriously difficult to identify if you don't have teeth. It could be a monkey, it could be a human, it could have been anything. So we could see that it was an ape of some sort, but we couldn't go beyond that. So we managed to arrange to bring Alesi to the synchrotron. And at the synchrotron, you have a process where they speed up electrons, they inject them into a tube that pushes them through a tube in the circumference of about the size of a football stadium, and then at strategic positions, this powerful magnet that will bend the electrons, and out of that you get this really amazing X-rays, these powerful, bright X-rays that can penetrate just through about anything. So I got the permission from the government to carry a Lessee. I still remember carrying that thing. I didn't go to the restroom, I didn't do anything. I was on the plane to Zurich and then to Grenoble. And when we finally had a Lessee locked up, I just went and had a beer. And here's a picture at the synchrotron. And what we revealed was that Alesi was beautiful, not just outside, but also inside. That often when you have things so well preserved, when you scan them, the inside is just solid. You don't see anything. There's no contrast. But in this case, it turns out that the contrast, the internal contrast, is just as beautiful. You can see the internal structures in a level of detail that was just unimaginable a few years ago. And so this is the meeting of our old paleontological techniques, meeting the cutting-edge technology, and we're now able to do things that are just beyond belief. So look at that. You can see inside, you can see the balancing structures, the semicircular canals, the hearing organ, the cochlea is in there on both sides of the skull. The sinuses, the malus, incus, and stapes in the middle ear are preserved. All the teeth that had formed up until that point are preserved, and you can blow them up and be able to count the growth rings like tree rings, and we can estimate the age of Alesi at a level of precision that was unimaginable. And we know that this baby, when it died, was about 1 year and 4 months, plus or minus 1 month. We can look at how the teeth develop from inception, when the roots kick in. So this chart here for the various teeth, and the various color will denote. So this line here is a line of birth. So anything on this side indicates a tooth that was the segment of the tooth that was the crown was forming before birth. So this is a prenatal development. This is a postnatal development. So the beautiful thing is that you can get this full series of the development pattern of the teeth. And this is something that we're going to be able to compare with living primates. And it's a kind of information that just was not there until now. So there's just a whole range of comparative comparisons and morphologies, all in one individual that we never had before. There's the cochlea, the semicircular canals, the balancing organs. There's the brain endocast. Alesi is right at the top, and then you have a series of compared to other things. So we're going to be able to look at the surface, at least the surface neuroanatomy. We're going to look at the folds. And some of those folds are pretty taxonomically specific. So there are folds that you only find in humans. There are only folds that you find in great apes. There are only folds that you find in apes. There are only folds that you find in monkeys. And we're going to be able to look at all of that. And so when we look at the teeth, we realize it was a new species. And in an old genus, the genus Nyanzapithecus, we named it Nyanzapithecus Alesi. Alesi means ancestor in the Turkana language. Ales means ancestor in the Turkana language. So Nyanzapithecus Alesi is Nyanzapithecus ancestor. So what else do we know? We know from our phylogenetic analysis that Alesi, the group, the Nyanzapithecans, what Alesi has done is that it has really helped us to sort out this group that are known as the Nyanzapithecans. Up until now, all we had were isolated teeth and a few jaw fragments. And it was very difficult to place them in this explosion of apes that lived in the Miocene. But with Alesi, with the full skull, we're able to clearly place the Nyanzapithecans as the closest thing that we have in the Miocene fossil record to the branching of humans and apes. So it would be, the whole group would be ancestral to all the apes and all the humans. And what does that ancestor look like? There's always been a debate about, we always want to know, what do these early ancestors look like? What do the ancestors of the human and the chimpanzee look like? What do the ancestors of the great apes look like? What does the ancestor of the ape look like? And I gotta say that it is an animal like nothing that is alive today. Evolution is a mosaic, and we always make a mistake when we start thinking about ancestors, when we have preconceived ideas in our heads about what we're expecting to see. That's how we ended up with Piltdown, because we thought that, when we go back, this is what we should expect. And of course, we got played for how many years? 30 years or so. So when you go back and you find this missing links, they're not going to be a chimpanzee. They're not going to be a gibbon. They're going to be their own thing. They're going to have some features of some of the living things, and they're going to have things they're going to have combinations of things that you don't see in living things. So you got to be very, very careful with that. So we know that in terms of the length of the face, you have four ape lineages: gibbon, chimpanzee, gorilla, orangutan, and then humans, so 5 in total. Two of them have short faces, that's humans and gibbons, and 3 of them have what? Long faces. So we want to know, did that last common ancestor, was it long face or was it short face? But I think with Alesi, we can see that they were short-faced, But in other features, they didn't look like gibbons, so they were short-faced like gibbons and humans. But in other features, they were not. So we know that the semicircular canals, for example, they don't look like gibbons. Gibbons have semicircular canals that are built for this acrobatic movement that Alesi certainly did not evolve in. So I would say that overall, the face of Alesi looked like a gibbon, but Alesi was not a gibbon. There were other features in which Alesi looks like monkeys, There are features in which Alesi looks like great apes. The semicircular canal looks more like great apes. Not like monkeys, like great apes, but not like gibbons. So it's a chimera. It's a creature of its own. It's a beautiful creature of its own. And so, why should we care? Why should we care about apes? Why is it that we cannot understand who we are without considering apes in general? Well, I'd like to point out that when Huxley gave us this image, and they say a picture is worth 1,000 words, he also sneaked in a very powerful idea that predates evolution, but somehow he managed to get sneaked in past Darwin and has become formed a very strong, has a very strong influence in how we think about evolution. And that's, evolution is this process of linear progress, a march that inevitably leads to us. And that's why people ask questions like, if evolution is really true, how comes the chimpanzees are still around? How comes the chimpanzees have not become humans? Because in our heads, we're thinking that the whole point of evolution is to do what? To turn everything into a human. So the chimpanzees now, 7 million years, should have turned into humans. When you live here, Google human evolution. You're going to get thousands, and look for images. You're going to get thousands of images, thousands of images. And I can assure you that 95% of those images are going to be the marching apes or marching whatever. So Huxley slipped that into evolution. I don't know whether it was inadvertently. I don't know whether he, maybe he didn't realize what he was doing. But that's not evolution. And if you're only studying humans, you're not going to know what the overall general trend and pattern looks like. And that's what we want to know eventually. We want to know what long-term trends and patterns look like. That's what we're trying to get at with these images. And only by studying apes are you going to get to what the long-term trends and patterns look like. The idea of linear hierarchy goes back to Aristotle. It's one of the most enduring, powerful ideas that we use to organize ourselves. The racism and whenever we construct societies that are hierarchical, that are based on a caste system, and America is a racial caste system, is fundamentally based on this idea that linear hierarchies are natural. Very powerful idea. But when we study apes, we find that there are a lot of them, and it's a tree. So I mangled the original one, and I added in the crazy uncle, crazy grandfather side. Added in the ape. It's a tree. It's not a linear hierarchy. Darwin thought that this concept was so important that if you read The Origin of Species, 350 pages, and there's one diagram. And what is that? A branching tree. And we know that there were many other circumstances where Darwin was obsessed with drawing trees. Evolution is a tree. And if it's a tree, you cannot say that one branch is higher or better than the other. It fundamentally undermines the idea of linear hierarchy, which I think is at the very base of racism. And so, as we look to the future, 2015, we discovered a partial skeleton of an ape close to the site where we found Alesi. It's not a Lessee skeleton, but we have several bits and pieces. So I'm going to be going back in January to excavate at that site. I have assembled a team of 16 specialists on various aspects of the skull. And we're coming together in March, and we're going to have a 3-day workshop, and we're going to brainstorm about how to properly analyze the Lessee. My advisor, David Pilgrim, used to say that paleontologists are like alcoholics. We tend to look for our keys where the lights are, not where we lost them. And so we have very little comparative data on babies, as Zerai would attest. Babies challenge us. We always want to compare adults. We don't want to deal with babies. So we have very little comparative data on babies. So we need to collect a massive set of babies and figure out how we're going to properly analyze and understand the biology and the evolution of Alesi. And so we're coming together in March to start that process. I've also put together a very large team of scientists, 26 people and counting right now. And we're going to be looking at the whole of the Miocene in the Turkana Basin. We're going to be doing a comprehensive integrated study of evolution of the Miocene in the Turkana Basin. We have a climate modeler. Look at alt-tilt, position of the continent, and all these other variables, and model for us what the climate should have been what the temperature should have looked like in the Miocene. We have people who reconstruct environments using isotopes. We have then people who are specialists in paleotectonics, because the evolution of the rift and the uplift of the East African rift system is thought to have played a very significant role in the vegetation and the climate of the East African region, leading to the origin of humans. So we have specialists in paleotectonics who's going to be looking at the uplifting process for us. And then we have paleobotanists, and we have people who look at fauna. So we're going to look at how the movement of the plates and uplifting has interacted with climate, and how those two in turn have shaped, or if they have at all, the evolution of the vegetation, and then the evolution of the mammals. And hopefully we will begin to understand why there was this great empire of apes in Africa during the Miocene, and by the time we get to 5 million years ago, the empire had disappeared. I'd like to thank the Leakey Foundation and all these other people for supporting my work. Thank you.
Thank you so much, Isaiah. That was a terrific talk. We're going to have questions now. And if you have a question, we should have people with mics. And if you just raise your hand, they can find you and take your questions. And we also have online questions, which should be coming in as well.
Even though you haven't had your conference yet, do you have an estimate of how large the adult version of Alesi was?
Yes, we did. We ran some regressions, because there's some correlation between the molar area and body size. And we ran some regressions, and we're thinking it would have been about 11 kilograms as an adult.
We have one online. The skull looks a little asymmetrical. Is that due to how it was preserved?
Yeah, the skull is just a little bit crushed, just a little bit, distorted. And we have one of the world leading experts in reconstructing and removing those kind of distortions. Over at the Max Planck Institute, there's going to be a part of the second tier analysis, and one of the things that he's going to be doing is to correct those distortions. And so one of the things you should be looking forward to is Alesi's skull without the distortion. Because one side is, the other side is not, so you can, there are ways of correcting those distortions, so we have it looking more accurately.
You have a lot of information about the teeth of Alesi. What does that tell us about the diet that
Right.
Alesi?
So generally what we find is that in apes and primates in general, that there's the primates that eat leaves have this cutting, cutting edges in their molars. And then those primates that eat insects have these pointy caps for puncturing the chitin, and the primates that eat fruit have these bulbous caps and basins for crushing fruit. And unless it looks more like a fruit eater. And also the incisors are very stout. Yeah.
How many synchrotron endocasts of other ancestors do we have? Are there more opportunities for research with this technology?
As far as I know, there are not that many. There may be only three right now. The Dekika baby that Zerai discovered is one of them. I think it was probably the first one that was a human skull that was done there. There may be modern humans or more younger things from Europe that have been scanned, but I'm not sure. So, but it's a really, really, really new technology. And the synchrotron right now is the only place where you can do it. Now, I can also report that Stony Brook is responsible for running the Brookhaven National Laboratories, and we're in talks. In fact, I'll be there on Monday, and we're going to tour the facilities, and we're trying to work out an arrangement so that they can adopt one of their beam lines, so they can do this. We can start doing this kind of thing in the United States.
Thank you very much for the wonderful presentation. And my question is a little bit maybe off topic, but that covered by volcanic ash forest is in a way 13 million years old Pompeii. And one of the most striking things in Pompeii, it was those cavities which decomposed bodies of the people who died there were. So is there any possibility of finding something like that there? Or is it just too many years passed and that was all packed and disappeared?
Yes, I think this was the amount of ash that was thrown down in this place was way more than what you found in Pompeii. You know, things were completely buried up, and in those kind of conditions, the bodies are going to disintegrate, and so I don't think you're going to find anything. But I never say never. In fact, what I'm hoping is one day I'll find a mummified body of an ape, but I think it's highly unlikely. Yep.
What are the most challenging issues or conditions when it comes to field work?
Honestly, frankly, I think that the most challenging issue is finding money, is finding support. And because I love being in the field, and I think I'm not bragging, but I think I have a natural knack for putting things together. I have a head for the logistics, and I just like being out there. And but in terms of physically, it's tough work. I mean, it's really arduous work. The temperatures are 100 degrees every day. You're sleeping on a ground, hard ground, because you just have a bedroll. You're eating the same diet every day for, in 2016 we had a 2-month-long field season. We were out there for 2 months with American students, by the way. And one of them has decided to become an anthropologist. And, so it is physically challenging. Long hours of hiking, long hours of sitting around and excavating. It is difficult. It is tough.
I had a question about the environment. I know you're about to do more research to try to get information, but what do you have so far? Are those trees of the same epoch as Alesi, the botanical specimens that you refer to? What kind of other remains do you have that give you a sense of how the habitat was?
Yeah, we always have to go through a lot just to know what the vegetation looked like. Often you're spending months and years just to figure out whether it was a forest or a grassland or a woodland or whatnot. But in this case, you have the whole forest. The whole thing is preserved. We had a paleobotanist there, and she mapped the trees that are still, where the stumps are still standing upright. 98 stumps still in situ, in position. And so in the forest or close to the forest, I say in the forest, are fossil elephants. We have fossil rhinos. We have one thing we find a lot of is hippos. We have fossil hippos, and we have another ape in there. We have an ape that is a larger species than Alesi, but we only have a canine. And in those postcranial that I showed you, it looks like there are two things in there. There's a small thing and there's a large thing. So and the site is such that you don't find much. In fact, when the geologist Craig Feeble came, he said, the conditions are such that you're not going to find much. There's no sorting mechanisms that collect things together. He said, you're not going to find much, but what you're going to find is going to be really good. So we don't find much, but what we find is excellent. And we've only been there for 2 seasons.
Our last online question. What do Alesi's large eye orbits indicate about the species anatomically or behaviorally? Is it because they were young when they died or nocturnal?
Yes, those cute eyes, I mean, they're just so cute. It's the first thing you notice. He says, why are those eyes so big? That's what we were all asking. Why are those eyes so big? Why are those eyes so big? And it tells you that we really don't know that much about babies, because Christopher Gilbert, one of the folks that I'm working with, did a regression line where he took body mass and a surrogate of body mass, and he regressed it against eye dimensions, and it falls right on the line. So the eyes look big, but not compared to other primates of the same age, that it's got the eyes that it should have. So what it tells us is that babies have big eyes. And it's just a growth thing, that the eyes grow fast and then the rest of the head catches up. Right.
You put the Alesi in between, in this diagram that you showed, you put it between an older find and a newer find, and I was wondering whether you could identify a particular feature that evolved since the previous find and preceded the next one.
Yeah, that's a very difficult thing. That's, because you have all these bumps and the teeth and whatnot. They drive me crazy. So I'm not going to try to even tell you what bumps on the teeth, But one good character that we never had before, that we now have, is the external auditory meatus, and it's a bony tube, that in the South American primates, it's not, you have a cartilage. And we'd never had, in the Miocene things in Africa, we'd never had one of those before, so we didn't know whether they had them or not. There was this thing that was discovered in Spain that is called Pliobates that they thought was what we're claiming Alessi to be. But if you look at Pliobates, it doesn't have complete bony ear tube, and that's a very, very good character that we know separates the catarrhines from the platyrhines. So the rest of the characters are going to be, it's going to be a complex mix of characters that I cannot list.
Any more questions, Al? So I just had a couple of closing remarks to make here. The C2ST has an evaluation form at the table. It would be wonderful if you could stop by and fill that out. Let us know how you like the program. And you'll be entered to win a 3-day pass to the Morton Arboretum. So it's a little, one day, I'm sorry. There are 3 of them? 3 of them. Oh, okay. In any event, you'll get a prize, perhaps, if you do that. This program has been recorded, so you can view it again or share it with those who couldn't be here tonight, but who would be interested in this wonderful topic. And it's a C2ST TV YouTube channel. And again, thank you all for attending, and to our streaming audience, thank you for joining us.